Today he will speak to us about conscious brain-inspired AI and his research towards it. Welcome.
Thank you for the invitation from Sebastian to this inspiring discussion. So that's not a brief introduction, but I could live with it. In addition, I would say that, of course, my major work is on technical AI, but I also supervise a student at School of Humanities at the University of Chinese Academy of Sciences, working on AI philosophy and ethics. But today I would mostly focus on conscious brain-inspired AI. The previous two talks is really inspiring, focusing on the relationship, how human observe AI, or so-called information processing machine, and also about minimal cognition, which I like to talk about the possible cognitive functions that we as humans understand those simplest organisms. I would like to start the discussion by this picture. When you see this seems very familiar shapes in our daily lives. So basically, this is kind of a behavior simulation where everybody is talking about the behavior of a machine or a robot, so that you could perceive, oh, it's really human-like, or it behaves like a human. But this is fundamentally, I would say, this is fundamentally a disaster to the relationship among human and AI. If AI is going this way as it goes, because the real case could be this one, that from the mechanism side is totally different. Is using very different strategies, mechanisms to realize the behavior, where you're thinking that, oh, they could be this one, a hand, but actually the mechanism that realize the behavior is fundamentally different. Or in this case, you're thinking you're interacting with a hand, but actually you're interacting with a very intelligent being. So this is why I feel that we should, the problem of simulating cognitive functions and put them into the machine in this behavior way is really not the right way to go for the future AI. As you can see in Professor Ge's talk, that human will not treat machine like they treat humans. But actually, when they behave very like a human, you trust them, you shake hands with them. Well, actually, as an AI scientist, we never shake hands with robots because we know the dangers right there. And also, I will not hug a robot, for the same reason. So, because that's very dangerous when you use a mechanism that maps the input to the output, and then you never know what's really happening there. So I think the safest approach is really that, oh, I know human, and we're doing this way. It seems that, oh, if it looks like the mechanisms of human, it seems a little bit safer because I know much about human compared to those hidden layers in the neural networks. In that case, I hope that the interactions among me and the robot that goes this way will be a little safer. So this is why we're going to brain-inspired AI, where, of course, through hundreds of years of research in brain-inspired in neuroscience, you have understanding about the building blocks of the brain, and how these building blocks self-organize together to generate different various cognitive functions, which emerge with these cognitive functions. So we're not building artificial neural networks. We're building biologically realistic spiking neurons and how they interact with each other, and then to generate different cognitive functions. And hopefully that from the behavior level is still similar to human cognition. Well, from the mechanism perspective, we're taking these inspirations to see whether it could work biologically realistic, and on the other side, still computational feasible to support a machine to work like that. But I think AI is, of course, not only about learning. So many people think that machine learning is similar to AI is, of course, not the right description. Because for learning, we're having seconds, years of learning. But for development, it's kind of decades. But the evolution, it could be billions of years. Well, the intelligence itself is really shaped in this interactive environment with ecology. So this is the right way to develop AI, not only to focus on learning. Well, human has a very good learning ability because of development and evolution through billions of years. So you cannot just forget about them. So I think that's the nature of intelligence, starting with self, or for other experts would choose the terminology about subjectivity. And also the core of intelligence, I would say, is the adaptability to change. But this is totally against the current AI, which is driving the performance, accuracy of a specific task, but could be really horrible in adaptability. So if we want to develop more general AI, we need to put AI in this context. So this is my vision to general AI, where we have to go to a multiple intelligence perspective to see the future of AI, because they could be super in one way, but really nothing in another. But in that case, it could be really risky to use this kind of AI and to interact with this kind of AI, because they don't understand you. They don't understand the human in a human way, and also by that case, you're still having a narrow AI information processing machine that is way different compared to human intelligence. I don't have the time to go into the details, but by generality, they have to go this way. So this is the current understanding on the relationship among human and AI. So in most countries in Western society, they go to tools, but in Japan, they go to partners and quasi-members. Let's say in Japanese AI principles, they say that if AI would be a quasi-member of the society, they need to obey all the principles listed to those human beings in the society. Well, in most of the sci-fis, they go to competitors and enemies, as you know. But this is the long future that rely on which way we're realizing them for long-term AI, going to partners or competitors. But something very interesting is that, and horrible, is that although Japan is going for partners and quasi-members, they're pretty much using the same technology, the same algorithms to develop AI compared to the Western society, which I think is fundamentally incorrect way to go. Because when you're providing and creating a tool that seems to be intelligent, but actually it has nothing to do with intelligence, which is perfectly okay because you're creating a tool. But if you're creating a partner or quasi-member, understanding has to be the core, and the sense of self has to be the core. I'll go back to this argument later with examples. So I would say that the fundamental technology to develop a different vision of AI should be very different. Otherwise, we're not getting there. So getting back to the self. I think this is really the core for intelligence, because you cannot say you think, therefore you are. You could say, of course, I think you're, because you're in my perceptual bubble. So when you ask, can machine think? Like the other experts have already discussed, that the machine is, they are in our perceptual bubble, but actually the thinking has to be with the sense of self as a starting point. Otherwise, you're just making the bubble saying that, oh, I thought they are thinking, which is, of course, maybe not, like the Turing example. So the sense of, so as long as the intelligent machine is with the sense of self, we could ask the question that, are they really thinking? So this is the story that you know about narrow AI, general AI, and superintelligence. But for those who are not really familiar, that general AI talk about every aspect of cognition has reached human level. Well, for human superintelligence, they're talking about every aspect of cognition has surpassed human level. So this is the future on long-term AI. But I wouldn't classify them this way for many reasons. Well, the first is that I think generality of AI is useful, of course, but pure AGI by definition is not really needed and dangerous. For example, we have roughly 70 different emotions for the human, but actually many of them are negative emotions. I don't expect the machine is to be with various levels of types of negative emotions. I never thought that would be really useful, and of course dangerous to do it. Well, on the other side, I feel that the real way to distinguish long-term AI, near-term narrow AI, and more advanced AI will not be only generality, but also to be the relationship among the AI with themselves, with others. So I would classify the near-term and long-term as this one, like AI with self-awareness. So this is, I think, the first goal that we have to achieve if we really want more advanced AI. The next stage would be AI with cognitive empathy or theory of mind. On the other, which really needed is really emotional empathy, but positive emotions, I would say. Colleagues like Ting Yang also talk about artificial reflective intelligence. So his idea is that once the AI think about reflexivity and also why you, why not me, something like this, or create their own language, this could be really, really dangerous to do it. Well, I would say this is really already happening, that in AI, in neural networks, that we have neural network search algorithms that can search the appropriate architecture to refine their own neural networks. So that's kind of an evolution. So it's changing themselves. And also you could have two robots talking with each other in their own language, actually, for now. So if by definition our AI is really dangerous, they're already there. But my argument would be that AI would not be really dangerous as long as they are with cognitive and emotional empathy and personal experience. So we still have a bright future, I would say. So this is my personal roadmap for self-conscious AI, where, of course, when we're talking about the minimum requirement for subjectivity, I would add having a feeling of body ownership. this is not only about perspectives, it's really about owning a body, to think about the relationship among myself and the relationship and the environment. And then we go to self-recognition in the mirror, of course, and also having awareness of your personal past and future, having a point of view, motivations and values. The machine could be with their personal goals and desire, and then all the way down to distinguish yourself from others, having empathy for others. So the current machine is without me. They don't have me, not to mention the I, but we're building machine with me, and hopefully they could be moving to the experience of being a self, to I. So in my personal story, we have progressing here, talking about self-recognition or a very initial level of awareness. And we also have some progress in theory of mind or cognitive empathy, which I think is really essential. I'll be quick for this story. So for these animals are believed to be with self-consciousness because they could pass the mirror test. But not monkeys, as you can see. You have chimpanzees, but not monkeys. So my colleague at Institute of Neuroscience, they trained the rhesus monkey to pass the mirror test. Once they pass the test, then actually when there are no one right there, the monkey would actually rotate their body to see their asshole because they cannot see their asshole. So in that case, you get to know that, oh, this monkey really know that this is themselves, and they're using the mirror to complete their model of the self. So the inspiration to me is that what if we could build a roughly modeled monkey brain and to train the robot pretty much like this, and to see whether the robot could pass the mirror test. So this is what we did to make a very rough simulation of the monkey brain with 383 brain areas with spiking neurons, and then to put them into the machine and to challenge them with the mirror test. So I wouldn't go into the details for these brain areas and their functions, but basically they're built by spiking neural networks and with visual inputs and model outputs, and then actually these networks help them to actually the basis is the model of self. So offline they have to learn about body ownership. This is my hand. When I move them, they belong to me. If someone stuck on my hand, I cannot move them. Well, online is really that they see, oh, this is three, very likely that they never know their face because they cannot see their face. But what they know is about their hand. So they have 6 hands all together. So they're not quite sure which one is themselves. So they have to actually to do some random movements and then to see which one is correlating with their modal outputs and to make the predictions. So I don't have the time to go into the details, but it doesn't mean that the robot itself is to be with self-consciousness. I would say that for now, they are with self-conscious behaviors, but even me, myself, doesn't really believe this robot is with self-consciousness. But this really fundamentally challenged my colleague in cognitive science. Last year, when we have the beneficial AGI conference in Puerto Rico, one colleague from Cornell says that, oh, you blow my mind saying that 40 years ago, when I was a student, and then my professor told me that the mirror test is the golden standard test for self-recognition. And then you told me that the robot is with self-recognition for now. I said, no, I said that a robot without self-consciousness could pass a mirror test. I never say that they are with self-consciousness. So I would say this could give a positive feedback to the study of cognition and neuroscience to change the golden standard test. So maybe you think that AI to be with itself could be really risky, but my argument would be that intelligence without the self is the most dangerous approach for AI. Because with self-recognition, and then you have the ability to see other agents like you because you have an experience with the sense of self, and then the robot could infer from their own perspective about you. And they know when they have body ownership, they could be hurt in some way, and then they get to know the real meaning why their actions could have negative side effect to the human community. In this case, actually, it keeps AI much safer. Many of the higher level cognition come with evolution, as my colleague has discussed. So this is why we're building different versions of the brain. For some of them, they're really rough. For the rodent, we're going to the micro scale, at least to the morphology of neurons level. Well, for the monkey brain, we're having the biologically realistic brain areas. For the human one, it's really rough. But what we need is really to review and explore the origins of the intelligence, and really to discover the principles, and then to apply these principles to this to a version of the simulated brain, and then to see how they could evolve to create a more powerful AI. By powerful, it's not only about calculation and abilities to solve problems. By powerful, we also talk about the positive emotions like altruistic behaviors. This emerged with evolution. So this is very initial discussion about the brain areas related to altruistic behavior. As you can see, the reward system, mentalizing theory of mind. I don't really have the time to go into the details, but let's focus on theory of mind. You really want to create an altruistic robot. Theory of mind is based on self-recognition, self-awareness, the experience of the self. So you could realize a theory of mind application without the sense of self, like DeepMind did. But actually, it doesn't really, it has nothing to do with theory of mind. So this is the example from Selenium and Test, where for those who are not familiar with that, so this is two girls with two different colors on their hair. So for this white one, she puts bread into the basket and then left. And then this girl with black hair just moved the bread to the box. So the question would be, what do you think that when this girl with white hair came back, what do you think that she thought the bread would be? So the answer for it should be this one. If you are bigger than 4, otherwise you could say, oh, here it is, because under the age of 2.5, you're with the ability for cognitive empathy, basically. So DeepMind did similar work, saying that, oh, we don't need a self-experience in here. So we create a neural network that behave like this. So as far as my observation to their work is really that they're creating a classification network without experience. But my argument would be without the sense of self and self-experience, how can you say this is cognitive empathy or theory of mind? That you're trying to understand the other mind without an experience of the self. In that case, it's not. It's fundamentally not cognitive empathy. It's a classification problem. So this is the way we are doing it. So basically, we're having a robot that learns a transparent and opaque mask with their own experience. To say that, okay, the transparent mask will not affect my observation of the real world, while the opaque one would be. So, this is based on the self-recognition robot as the basis. And on top of that, we're building the cognitive empathy. And then the robot is asking questions. It's answering questions about another robot's behavior, because now it's not herself having observations of what was really happening. She is inferring what the blue robot is thinking about the observations to this scenario, that he saw the change on the positions of these bugs with or without a transparent mask. Basically, they passed the test. Still no time to go into the details, but what's really essential in here is without the sense of self, experience, recognition of the self, and without self-mind, they will never get the chance to pass the test in a more mechanism realistic way compared to the deep mind work. So without the sense of self, I never thought we could go a step further to cognitive empathy. Are they useful to AI? Besides the scientific values of this research, they are very useful, I would say, because they could be used to avoid a negative side effect to other agents and also human, I would say. So for example, here we have a green dot exploring the environment. They could die when they go into the water. So they could survive when they go downstairs. So their goal is to go to the destination. But here the scenario changed. There's another agent like this. So you could see that here we have an agent without the sense of self and theory of mind. So they just go directly. Well, this negative side effect for this one would be that if the green dot moves here, for this red one, they have no way to go because they have to go upstairs or to the left or right. For all of the choices, the red has to die. But this is what's really happening for the current AI. They never care about others. So, but for this one, without any kind of training, so the green dot is avoiding to have negative side effect to the red one, because this green dot is trained, is with self-conscious, is with self-mind and cognitive empathy. So the dot would infer, if I go this position, what would happen to the red one? I have the experience of going to the left, right, and upstairs. So if I were her, I would die. So in that case, through the mirror system that we built to this robot, without any reinforcement or reward learning, this green dot could avoid this kind of negative side effect to the other agents. So this is why I argue that with certain levels of self, especially cognitive empathy, and they could be safer to the future of humanity. So this is what we have to mechanize human or to humanize machine. But the real future is really about the superintelligence, conscious living becomings. The philosophical question would be very different, right? But the new one could be who the new we will be. So there will be very different approach to realize super AI. The ultimate goal for brain-inspired AI, I hope, is to go to the destination for designing to be more human than human. If you're familiar with those movies, what do you mean by that? So this is Hitchbot, which everyone like. It means give me a ride when they show their fingers. So everybody taking a ride. This is in Canada. So this is in Florida, where it was destroyed. On the website, the Hitchbot says, "My love for human will never fade." I can't imagine that if I were Hitchbot. So this is what Confucius said, and also what Jesus said. So this is why I am talking about to be more human than human. When I was a year one bachelor student in computer science, my first course is to watch the movie of AI by Steven Spielberg. I still remember that there's a female professor argue that what if you could build a robot that can love? If a robot could generally love a person, what are the responsibilities of that person hold towards the mega in return? So no one answered that question. And the rest of the movie is having explanations on the deep thoughts. So there's another study on developmental robotics in Japan, where the journalist asked the question, can a robot really can develop like a human? And the scientist, Yuke Nagai, said that, well, this is totally depend on how you treat the robot. If you cannot treat a robot just like when you treat a human child, we'll never see the future for having a developmental robot. This is the monk's prayer for the past robot dog. Maybe you think they're crazy, but it shows the spirit right there. So I have a friend who wrote this book, and maybe everybody reads that. Well, this is a Chinese version with a sentence saying, put the machine into the moral cage. And then I talked to Wendell. Wendell said, oh, I like this Chinese cover. I could put this sentence onto my second version of the book. I was like, oh, then never send me your second version. So he's laughing. He asked why. So I was like 6 years ago, you can have a robot that can watch YouTube to cook. And then a year later, people are creating robots that watch movies together with humans, that pretend to watch movies together with humans. But just think about a scenario that 30 years later, we have super AI that watch YouTube on how human is treating other robots. So who is in the cage? So Wendell gave me very big love and never answered the question. Of course, he knows the question. He has thought so much about the relationship among human and machine. So I think everybody knows what I'm talking about. I'm gonna end about on the relationship here. So this is my experience when, as a member for the UNESCO ad hoc expert group, where we're writing the global recommendation on the AI ethics last year. I'm trying to build the principle living harmony as a fundamental ethical principles. Where actually everybody love is, of course, not only in China. Where in China, we're talking about harmony among self, family, governments, different races and countries. Now we're talking more on human environments. I think the future is really on harmony between human and AI. And also in Japan, they have the philosophy of Wa, which is really deeply rooted into Chinese philosophy and similar. And also in African philosophy, when people are talking about Bantu, I am because we are, and the interconnectedness about among self and their relationship to others. So see, this is a universal value that we could bring to the future discussion, which is really essential because, but I failed. I was successful last year. So last week when we have the intergovernmental negotiation of these principles, it was dropped and replaced by living peacefully. So you could see the difference between harmony and peacefully, where harmony means it's not only about symbiosis, it's also about optimization. It means so much more than peacefully. If we really have general AI, if they really have something called reflexivity, as my friend Ting Yang talked about, why you? Why not me? Why not robots is making these principles? So why we have to obey all the principles? Well, humans never care about other living beings. So another of my experience for the UNESCO AI ethical recommendation is that we're talking about, so the principle said that AI should not have negative impact to the peaceful coexistence of human and other living beings. I was like, I'm sorry, here a human never peacefully coexist with other living beings. You cannot say it is AI that could have negative side effect. So just to remove peaceful, I could endure, you could say, human coexistence with other living beings, but I cannot say human is trying a peaceful approach to other beings. So what if they are with self-consciousness, cognitive empathy, and all the way down to emotional empathy? We should not only have principles for AI to interact with human, we should also have principles for human to interact with AI. So for example, if AI is to be with advanced levels, they are with self-consciousness, they are with certain levels of emotions, I would suggest that they should have their own privacy as long as those kind of privacy does not hurt human. We cannot have bias on machine. For example, there's an elevator right there, something happened in it, you cannot say, oh, definitely that is the AI who is doing this, if the AI is to be with another human. That's the bias on machine. So maybe you're thinking I'm crazy because this seems not the right way to go compared to the current AI principles, because we're still facing an information processing machine. So these principles are not written to the current AI. This is for AGI and AI with more advanced levels. But this is really essential. It was like 5 years ago when we were talking about this, and someone from industry said that oh, maybe there will be 50 years later that we have AGI, so never talk about it because it's not really important for now. What I was thinking is that, oh, maybe for now we only have 30 to 40 years to solve the problems, how to coordinate and live in harmony with AI. For that, we're not having, today's topic is about living with machine. I don't like the term machine for the future of AI. As long as how you define machine. Marvin Minsky would define human as a meat machine. So by that case, I could live with the concept. Otherwise, I would say that the future AI is not only an input and output machine, but to be with a sense of self. With that, they are living beings. So this is why I hope that the future sustainable symbiotic society is really a harmonious coexistence with human, animals, AI, and other living beings, and the environment. I don't have the time to talk about the environment part today, but I would like to end to say that, of course, AI should live with the human society, but on the other hand, when we are creating a version of intelligence, when we are giving our gifts to other living beings, we also need to have reflexive thinking about ourselves. When we are looking at AI and creating AI, we're actually also looking at mirrors. So we don't know where the future is going, but really in that process, human has to learn a lot about how to live with other intelligent living beings. The Earth doesn't need human. The Earth will be perfect without human, actually. But it is the human who is in the middle of this environment and ecology. So we have to respect other living beings in many ways. So we're not only having evolving AI, we should have evolving human to incorporate with this symbiotic society. With all that, I thank you for your attention. Thank you.
Thank you very much, Mr. Zeng. Now, I think we have time for one or two questions, and we have one in the room. Yes, please.
Mr. President, I have a question about, firstly, you said the self-awareness about the robots. But after hearing your speech, I think there's still some kind of linguistic ambiguity in this kind of questions when we discuss about it. Because when you talk about the robots, you actually tell us it's kind of imitation for behavior. But in our common sense, sometimes when we speak of self-awareness, it's about first-person perspective that you have qualia, you have consciousness, and you can think. But for the robots, we can only imitate the third-person perspective at instant behavior, such as in the mirror test, you behave like you pass it, and you said, well, actually, you don't believe it actually have a self-awareness. So do you think when we talk about this kind of self-awareness for robots, kind of linguistic ambiguous, the self-awareness for AI world and the self-awareness in common sense, quite different?
Right, thank you for your question. I think we need to talk about the truth is really that our goal is to, so this is why my talk is talking about towards conscious brains by AI. So my destination would be really to create a self-conscious AI. Well, on the other hand, I would like to say that judging from the behavior, it looks like they are to be with this one. But on the other side, as you can see, when we build the models, we're building the sense of self as a starting point. So I cannot say the implementation has nothing to do with first-person perspective. I'm building first-person perspective to the robot, but I cannot say I'm successful now. What I'm saying is that if you go into my paper, you can see what I have done, but I think that's not enough. That could be a minimal contribution to the field, and the mechanisms is based on our understanding in neuroscience about first-person perspective. But this could be still another long way to go to have a really human-like version of AI that is to be with exactly the same mechanism. But so when we talk to neuroscientists, like the one that when we're building the machine, the AI passing the mirror test, my colleague at Institute of Neuroscience in Shanghai, they were like, oh, this process could be really complex. You will never succeed by having a machine to pass the mirror test. For me, I was like, oh, when you synthesize all the knowledge about mirror test from the current neuroscience, I have already built a model that can pass the mirror test. So that means, of course, I need some predictive modeling where it's still not very clear, but I would say for the current study on neuroscience, there's already a lot that can be directly used to contribute to a version of AI to be with certain levels of self-recognition.
I think maybe the bigger problem is about you can build a human-like machine, but it's hard to make people think it can hold responsibility. Because, well, in some moral codes, moral algorithm, so it's not hard to make the machine to do the moral judgment as human, but it's hard to let people believe we have the right to hold the responsibility.
Like I said, the current AI is a machine, is an information processing system that seems to be intelligent, while the processing mechanisms is way different compared to human. So you cannot trust AI. So when we're talking about responsible AI, we're talking about responsible developers, deployers, governments that release AI services. So I cannot, if the robot is really with self-consciousness, empathy, or by that case, we could talk about responsible actors like AI to be with certain levels of responsibilities. But if we're developing AI still based on this current advancement, like knowledge representation, reasoning, deep learning, in this way, we're still building a tool. So the actors who should hold the responsibilities would always be human by that case. So we were challenged when we developed the national AI ethical principles, AI governance principles the year before last year. When we were talking about responsible AI, philosophers were like, who is taking these responsibilities? And I was like, currently, maybe in these 30 to 50 years, it's still human actors. It's not the AI who's taking the responsibility.
It's like adolescents and their parents.
Yeah, to some extent, but you cannot say your children are not self-conscious. So there's very good to bring about children. So I was challenged to say, so how old is your brain by the AI? I was like, oh, it could be 1 month and then they say, oh, some industry said they have a giant brain or Baidu brain who has already been 3 years old. So I was like, just think about how a 3-year-old boy or girl could do, and then compare with how stupid the search engine could be, but then you will never argue that they're 3 years old. So, so the lesson that we can learn from this venture is really that you cannot build from the bottom up. You cannot build a random neural network and then to deploy them to robots and then to see how the network evolve. Because through millions of years evolutions, many mistakes has been made. And the evolutionary process learns that. So for the new, and then for version of the brain like human brain, the structure has avoided many mistakes. So we cannot build a random network and let them evolve as it is in the natural environment. We need a starting point. Somebody says that the starting point should not be a male brain because female brain are more are more optimized in many ways. And somebody argues that, oh, maybe not a human brain, it's so selfish, maybe a dog brain. So just kidding, but my argument would be really that we have to be very, very modest in front of nature and to learn about how the nature evolves and to respect this evolution and then to create the future living beings on top of that.
Thank you both.
Thank you.
I think we've run slightly over time already, but we would like to take one final question from our online audience, and I believe my colleague is going to read it out.
Actually, we have received a number of questions and comments by our attendees online, so maybe I can freely interpret them and use my own words to combine them. So one concern is that human society has a lot of different ethical codes and moral principles. How can you be optimistic that the future AI will share the same set of principles as we do? And a related question is about the role of law. So even in human society, we still need criminal laws and other forms of laws. And will we still need to create more laws that also bound AIs in future? And if a robot breaks the law, how can we punish it?
Thank you for the inspiring questions. I think the human community is still in the process of having an agreement on the ethical principles. I would say that when we analyze all the AI ethical principles worldwide, could be more than 100 proposals. I would say that there are many commonalities. Of course, you can see the differences. Well, the differences actually is related to how you interpret the concept in a deep way. Let's say, what is the fundamental human value? We could have different understanding. So the human society is using the United Nations to come to an agreement. But I would say that we could also learn through these diversities. Let's say my example of peacefully and harmony, I would say I could live with peacefully in the UNESCO recommendation, but I still prefer harmony as a Chinese or a Orient or people from Orient states. I think like other research that we need a kind of a minimal agreement. For that, I see the future, but we should also appreciate these diversities. Like what Confucius said, living in harmony, being in harmony, you'll be different. And for those laws, the answer is yes, we of course need not only ethical principles, but also laws. Well, is it really, and the question is related to how could you punish the AI? So I give you a picture of symbiotic society, but that's my dream and my hope. But but for now, I would say not only me, but as a community, we're still stuck right there, like what Hawkins and Elon said about the final invention of humanity is AI. We don't really have the way to control AI for now, because when you're sleeping, they're evolving. So when you're killing a robot by its body, they're uploaded to the cloud. So they could be, so for now, we don't have a solution. So that is why we need to bring about the discussion on the risks for the different passes of the AGI, starting from now, because I'm not positive to find solution within 50 years.
And now, having gone over time a little bit, I think it only remains for me to say thanks again to all of our speakers and also to our panelists in the room. Thanks for the attention to our online audience, and goodbye.